In this video, I want to introduce function notation. Some of you may already be familiar with this, but so this might be a review, I'm not sure. So let's start with an easy function like y equals 3x plus 2. This is a linear equation or linear function, and it has infinitely many solutions. We know this already. You can make a table and you could find some solutions by plugging in a number for x, any number you want, because there are infinitely many solutions. So if you plugged in 5, for example, 3 times 5 is 15, plus 2 is 17. If you plugged in 10, 3 times 10 is 30, plus 2 is 32. So this is an input, output, domain, range, x values, y values. Okay. Another way to write this, instead of y equals 3x plus 2, we could say f of x equals 3x plus 2. And that's what I want to talk about in this video. This is called function notation. So it's the same thing. It means the same thing. Instead of calling this y, we're calling it f of x, a function of x, because y is the dependent variable. It depends on what you choose for x. That's what you get for y. So this is just another way of writing it. A question, you instead of plugging in values like that, you'd say what if, or rather what is f of 5, meaning plug 5 into this function. As you can see, the answer is 17. If I asked you what is f of 10, you would say 32. So it's still inputs and outputs. This is your x, this is your y, is the answer that you get. And that's function notation. It's not just constants that you can plug in. I could ask you what is, let's say, like f of x squared. So what I'm saying is, instead of plugging 5 in here, I want you to plug x squared in here. So you'd have 3 times x plus 2, but I'm asking you to substitute in, instead of x, just as you would have put in a 5 to calculate it here, I want you to plug in an x squared. And so you just get 3x squared plus 2. So you can plug a function into a function. Another example of that would be if I asked for what is f of x plus 2. So then it would be 3 times x plus 2 is your original function, and I'm asking you to plug in place of x, I'm asking you to put in x plus 2. So you can plug a function into that function. And then when you distribute, you get 3x plus 6 plus 2, which is 3x plus 8. Okay, so this function notation is this f of, and you can plug in constants or you can plug in other functions. Let me give another example. If you had, for example, let's see, f of x, push this up here, f of x equals x squared minus 3x plus 5, and I asked you what is f of 2. You would have to plug 2 into each x term. So the function is x squared minus 3x plus 5. That's this function right here. Instead of x's, I'm asking you what is f of 2, meaning can you plug a 2 in here and here. So it's 2 squared, which is 4, minus 3 times 2 is 6, plus 5. So 4 minus 6 is negative 2, plus 5 is 3. So if you plug in 2, you get 3 for an answer. Again, just like on your table, if you plug in 3, you get 2. So you would say f of 2 equals 3. Okay, inputs and outputs, that's all we're doing here. And of course, I could ask you something like, what is f of m? Well, the function is x squared minus 3x plus 5. That's this function right here. And I'm asking you to plug m in, so you're just going like this. So it's m squared minus 3m plus 5. It's the same equation as this, except instead of x's, they're m's, because I asked for f of m. Right? Okay, so that's that. I want to show you now that you can do operations with functions. So let me get another page here. So we can add, subtract, multiply, and divide functions. So if I was to define f of x as x squared minus 3x plus 10, and if I was to find some other function, g of x, as x plus 2. So these are two different functions. I can add, subtract, multiply, or divide. And the way we say that is, what is f plus g of x? That means add the two functions together. So it's very easy to add two polynomials together. You did this, I think, in Algebra 2. We are adding that function plus that function. So we're adding them together, and it's just a matter of combining like terms. So x squared, you've got negative 3x plus 1x, and 10 and 2 is 12. So that's the sum of those two functions. And of course, if you can do the sum, you can do the difference. X squared minus 3x plus 10, x plus 2, and we're subtracting. Now in this case, it's important that you use parentheses because you're taking this whole function away from this function. All right? If you don't put the minus at the parentheses, it's going to look like you're just subtracting the x, and it's going to look like a positive 2 to go with this 10, and which will make 12. But it's not, because you have to subtract both. So it's x squared, negative 3 minus 1 is negative 4x, and 10 minus 2 is 8. So those parentheses are really important for the subtraction. And then we could do f times g of x, which is the product of those two. This one's going to take a little more work because you're going to have to do some sort of, I call it FOIL, but it's not really FOIL. You're going to have to do some distributing here, because this has to be multiplied by all three of these, and this has to be multiplied by all three of these. So x times x squared is x cubed. X times negative 3x is negative 3x squared. X times 10 is 10x. 2 times x squared is 2x squared. 2 times negative 3 is negative 6x. And 2 times 10 is 20. And then we just combine like terms. We've got an x cubed. We've got negative 3x squared plus 2x squared. 10x minus 6x. And the 20. And that's the product of those two functions. And lastly, we can do f divided by g of x. So we just write f divided by g of x. And most of the time, a lot of times, you can just leave it like that. You're done. In this case, I set it up so that this factored. We know how to do this because we've just finished rationals. So chances are, if this cancels, this is also an x plus 2, which makes this x minus 5, because, yeah, did I do that? Did I copy that right? Minus 5. Oh, that was a minus 10. That didn't work out right. I picked the wrong number. That didn't factor the way I wanted it to. So we'll leave it for anyway. If it did, you would have canceled it, and it would have just reduced to a linear. But in this case, it doesn't. I didn't realize that was a plus there. So moving on. Now I want to show you something called composite functions. And that's just a function within a function. So textbooks use this notation f, this is an open circle, g, f of g of x. I prefer the notation f of g of x. Either one, textbooks use both. So what they're saying is to plug one function into the other function. So if I said to you, what's f of g of 2, well, let's do this. Going back to the original function here, if I said f of 2, you would write the f function, which was, let me rewrite these. F is x squared minus 3x plus 10. I'm copying this from up here. And g is x plus 2. That's from here. Okay, so I don't have to keep going back and forth. If I asked you what's f of 2, you would write the f function. So you say x squared minus 3x plus 10. If I said what's f of 2, you'd put a 2 here and a 2 here. But I'm asking you f of g of x. So what I want you to plug in is this g function, which is x plus 2, x plus 2, and then you just have to multiply it out. So squaring that, you get x squared plus 4x plus 4 minus 3x minus 6 plus 10, and of course you can combine like terms. X squared, you got a 4 minus 3, and 4 minus 6 is negative 2 plus 10. Okay, so that's multiplied out. That's f of g of x. That's called a composite function. It's composed of two different functions. But you can also do g of f of x. So you take the g function, which is x plus 2. That's my g function. And I want you to plug in f of x into that. So take the f of x function minus 3x plus 10. And this is much simpler because all you're really doing is saying x squared minus 3x, 10 and 2 is 12, and you're done. And that's a composite function. F of g of x, g of f of x. So we've got operations, adding, subtracting, multiplying, and dividing, and you've got composition of functions, and then just plugging numbers into functions. And that's function notation.